Hello everyone, this is Naushad. I hope all of you are doing really well. Do you know millions of hypothetical particles are penetrating us continuously? Actually, sun creates enormous amount of neutrinos continuously, and those hypothetical particles, the neutrino particles, are penetrating us continuously. So let's learn about the neutrinos. So we know there are a lot of particles which are not that much common to get or to detect, but they are very important to know the informations about the universe and some of the most important matters of the universe. Okay, so neutrino particle is one of them. So first of all, we need to learn about the beta decay. So after knowing the beta decay, we can actually know the neutrino very well. So before knowing the neutrino particle, we need to know the beta decay first. What is beta decay? So there are two reactions. One is carbon 14 to nitrogen 14, and another one is carbon 10 to boron 10. So we know, so if we go to the periodic table, we can find carbon, nitrogen, oxygen. So here's boron, carbon, nitrogen, oxygen, carbon to nitrogen. So it means actually beta decay means proton to neutron formation, neutron to proton formation. So proton to neutron formation, neutron to proton formation. So we can see carbon 14 to nitrogen 14, carbon to nitrogen. So it's negative or minus beta decay, carbon 14 to nitrogen 14. So we have two byproducts, antineutrino and electron. Another reaction is carbon 10 to boron 10. So carbon to boron, so it's positive beta decay. So we have carbon 10 to boron 10, and there are also two byproducts, neutrino and positron. So we are actually talking about these particles, neutrino and its antiparticle, antineutrino. So while beta decay, we see some problems. Like if we can name those problems, they are the conservation of energy. Conservation of energy. It means if we can see x plus y creates a plus b, the energy in x plus y creation will going to be the same while a plus b will going to be created. So that's the conservation of energy. So in beta decay reactions, we cannot see these similarities in left side and right side. It means if we have 100 here, 100 energy here, it has to be 100 here, but in beta decay we see 80 here, like the energy is not same. So there is a energy gap. So some particle or something has to carry those energies, and we don't know about it. So here comes Wolfgang Pauli. So Pauli comes with an idea that there will be a particle which is carrying that energy. So then it names neutrinos. So Wolfgang Pauli, like the Pauli's elimination method, we all read about it. So Wolfgang Pauli proposed a theory or something that there is a particle which is carrying those leftover energies, and this particle is actually known as neutrinos. Okay, so in positive beta decay, we see neutrino. The neutrino is created, and while there is a negative or minus beta decay, we see antineutrino with the electron and positron. These are the byproducts. Okay, so this is the actual story of the detection of neutrino. So now we will going to learn more about the neutrinos. So let me tell you two more informations about beta decay. So there is not only the conservation of energy is violated here, there are also two more problems. They are the linear momentum problem and angular momentum problem. Okay, so these are the particle related problems. So just for basic knowledge. Okay, so let's jump into the neutrino part. So this is the story how neutrino, we discovered the neutrino, or we came to the idea of creating neutrino, or there's something which is hypothetical and it is going to be a particle which is called neutrino. So from beta decay we discovered the neutrino. Now we will going to learn about neutrino. Okay, so where do we find neutrino? If we go to the standard model of elementary particle, we find fermions and bosons. So in fermions we have quarks and leptons. So it's where it's a particle. Quarks are unstable and leptons are stable. Okay, so leptons, there are four leptons. One is electron is considered as a lepton. Another one is tau and muon, and lastly the neutrino. So neutrino is a kind of a lepton. It's a subatom. All of them are subatomic particle, and neutrino relies on the lepton part. So it's fermions. So basically fermions are the reason for matter, the creation of matter. Okay, so that from the bosons are for energies. Okay, so we will going to discuss those things, the standard model of elementary particle, later on. So these are the elements, these are the particles which are considered as the leptons, and they are same. Like one is basketball ball, one is tennis ball, one is football. They all of them are balls, but one is basketball, one is football, one is tennis ball. Like they are balls and they have similarities because all of them are leptons. Okay, so this is the neutrino from a standard model of elementary particle. Okay, so let me tell you more about the neutrinos. So we can find three types of neutrino. One is electron neutrino, another one is tau neutrino, last one is muon neutrino. The electron neutrino, tau neutrino, and muon neutrino, it's similar to the lepton or another lepton particles. So these are the three category neutrino particles. And lastly, we will going to discuss about why we discovered the neutrino and why neutrino is very important to learn. Why I'm making this video. Okay, so why we are learning about the neutrino. So neutrino, we should learn about neutrino because there are certain properties of neutrinos which is very what should I say, very ghostly, because for that purpose neutrino particles are said to be ghost particles. Okay, ghost particles, because it's hard to detect them. Okay, like continuously in sun, continuously the neutrino particles are generating, or from Big Bang, when Big Bang happened, so that time actually a lot of neutrinos were emitted. So those neutrinos are still there, penetrating all of us. So if we can detect those neutrinos and study about the neutrinos, we can know the Big Bang. Okay, the informations of Big Bang, also the dark matters and dark energies. These are the informations. We can't know anything about these things. So neutrinos are from the beginning of the universe. So studying neutrino, we can know more information about dark matter, dark energy, and also the Big Bang. So, and also neutrino is carries a small mass, a tiny level of mass. So that's why its speed is so high, like it's near to the speed of light. That's why it's penetrating all of us. Okay, so it's penetrating because it has a tiny mass, and the speed of neutrino is nearly the speed of light. Okay, so these are the things. It's like it's the oldest subatomic particles, and we can study about the neutrinos. If we study about the neutrinos, we can know the what should I say, the horror stories, the ghostly stories, the more knowledges about the universe. So that's the end of this video. So that's a small introduction of neutrinos. So how we detect the neutrinos, the neutrino detectors are where we put the neutrino detectors, and there are also a lot of particles are there, like the neutrinos, like the Higgs bosons. Let me make a video on Higgs boson next. Thank you very much.